Okay, so this Wednesday, continue your lab if you haven't finished. Your task one will be in week 8, Wednesday morning, 8 to 10 a.m. In FAQS meeting room 2. Okay, recap what we learned in chapter 2. Not chapter 2. Yeah. Chapter 2, we only learn one equation only. It is all the force equal to MA. We only learn this equation. Then we expand. We relate the A from chapter 1. Which is the definition of S, V, A, and T. Okay. So here, chapter 2, you need to start draw free body diagram. Okay. So free body diagram plus kinetic diagram. Okay. Diagram you need to draw in chapter 2. And in free body diagram, what is important? You only deal with the left-hand side free body diagram. You deal with forces. Okay, you deal with forces. So what are the forces? What are the forces that you see? There are few forces only. Right. So weight, external force. What else? Two more. Weight is due to gravity. Force is external force. Two more in the chapter 2. Friction. Before friction, you need to find what? Contact force, normal force, and friction. So as long as there is any contact, then you have N. Okay. And remember, always 90° to the surface. Okay, as long as there's a contact, then there is a this one. Okay, on the kinetic diagram, on the right hand side, what you have? You deal with what? Mass and acceleration. So here, normally the acceleration here, you derive from chapter 1 question. Okay, you derive from chapter 1 question, definition of two integration. Of one of the tutorial question. If you're unable to find what you do, if you're not able to find anything from the A, use this integration formula to find. Okay. Right. Now, one of the tricky part in chapter 2, you need to consider whether acceleration is constant or not. Carefully. Acceleration is constant, you can use the equation, the 3 Newton equation, 3 Newton motion equation to solve. If it's not constant, then use this one. Okay. Or use integration. Okay. Right. So this basically will be in your test 1. Okay. All right, we continue discussing question. All right. So you look at example 5. Example 5. 3 kg disc D is attached to the end of cord. So this is the green color disc attached to one cord, right? And the platform will swing in anticlockwise direction. The radius is 1 meter. All right. Now, if you look at the question, you know that you have two kinds of motion. One is linear motion and collinear motion. So this motion is collinear motion. So collinear motion, you only look at tangent and normal direction. Okay. Now, the end of the cord attached to the ball and socket joint located at the center of platform. If the platform rotates rapidly, the disc is placed on it, released from rest as shown. Determine time it takes the disc to reach a speed greater enough to break the cord. Okay. Maximum tension of the cord can sustain 100 Newton. And coefficient of kinetic friction between the disc and the platform is 0.1. You look at the question, you know that this is not chapter 1 question. This is chapter 2 question. Why? Why chapter 2 question? Huh? No. Collinear is chapter 1 question. There's a few keywords inside there that identify that this is chapter 2 question. Chapter 1 question. Chapter 1, you don't have what? You don't have weight. What else? Friction. You don't have friction. Chapter 1, you don't have friction. Then what else? What else? Friction. Yeah. These are the few things lah. Then it tells you that there is a tension of the cord. Tension is the force. Right? So chapter 2, you deal with force. Chapter 1, you don't have force. Chapter 1, you only deal with displacement, acceleration, velocity, time. You do these 4 things. Right? So when you see, it gives you the most obvious one. If you see kinetic friction or friction coefficient, then this is chapter 2 question. Okay. You see kinetic friction already means you need to find the normal force. Okay. Now, the question asks you, determine the time it takes for the disc to reach a speed greater to break the cord. This is a design question. So you spin the thing, and then you need to find the time. It starts from the disc is placed on it and released from rest. So you release from rest, and then this one start to rotate. So when you start to rotate, here you don't know about the omega, you don't know the rotation, but it asks you to analyze just based on force. Based on force, based on mass that you know. Okay. What else? Okay. All right. So determine the keyword here is determine the time it takes for the disc to reach the speed greater enough to break the cord. So what is your focus here? What is your focus? The green color, or the rope here? The rope. Okay. The question asks you about the rope actually. Okay. But to find the rope, actually, the green object is the one that help you to find the tension at here. Okay. You have a tension cord of 100 Newton. So you can transfer the tension over here to this object. You learn in static, right? You know that force can transfer one, right? Okay. So before we solve, we have some logic thinking first, like how this question was designed. So you focus on the green object. So this one was tied to a rope. When it spin, what are the? Imagine you look from the top. This one was spinning like that, right? So what do you feel? You as this object, what do you feel from the rope? The rope punching into your body or pulling out from your body? Pulling, right? You are this object, you're spinning. You sit on the platform. Then as you spin, there is a rope attached to your body. What do you feel? You feel the rope punching in or pulling out? Pulling out, right? So draw. This is a tension cable. Okay. Then this is from the top. Then you know the radius to the center is 1 meter. It's R. Right? Okay. You know this is circular motion. Circular motion straight away break into tangent and normal direction. Okay. So then the rest, okay, now this is a draft before you start. At least you get what is actually happening to the question. You want to find the time to break this one, right? Meaning you need to find the time when this tension reach 100 Newton. Okay. And you know that this is chapter 2 question. Chapter 2 question, the only one equation you involve. All the force equal to MA. So you look at this your hand sketch here. Tension is force. Right? Tension is force. So all the force in tension will equal to MA. Means the direction in normal will give you the A. M mass of this multiplied by the normal acceleration will equal to the tension cable. Make sense? Make sense, huh? Okay. Because I'll try to guide you like how to solve question in chapter 2. You look at the question and focus on the equation for chapter 2. Then try to link what information you have. Then from there, you build the equation up. This question is not very direct. Okay. Usually this one, you see this one in a final exam. Right. Okay. So how do you draw free body diagram? Okay. So basically you have 3 axes. Z axis or label as B. Then as it rotates, you have normal and tangent direction. Okay. Normal means pointing to the center. B means tangent to the curve. Right. So there is a weight pointing in, pointing down, because this is a chapter 2 question. Chapter 2, you deal with 4 forces. Weight, external force, normal. If they have contact, then you have normal force. Once you have contact, you sure have friction. So these 4 forces is always in chapter 2, unless it's thrown into the air. Then you have drag. Then don't have any normal force. Okay. All right. Then because it's contact, the green object contact with the gray color surface, so you have a normal force. Right. You have a normal force pointing in. Where do you think is the friction direction should point to? Here, here, here. Where's the friction? Here. Okay. So friction body is pointing this direction. Why? Why this direction? This is the green body. This is the platform. So the platform, maybe I draw in 3D. So the platform will turn in this one, right? So if you split the two, this is the green ball, this is the platform. So if the two body contact, this one go here. So on the platform itself, if your focus is the platform move with this, so the friction will move in here. If you look at platform. But now your focus is on the green object. So this friction go here, right? It's go like that, right? So if I see, let me draw as. So if your friction from the platform is going in here, then the green one will be opposite of your. You must balance. The two force must be balanced because of the two contact surface. Okay, so it depends on where you see the object or what is your focus. So if you look at the platform, then friction go this way. If you look at the green object, then it go another way. Because it need to balance the force between the platform and the green object. That's why you see the friction is towards the tangent direction and not against the tangent direction. This one you need to think a little bit. And in your static, you never thought of this approach because static is always stay in that direction, always stay and static and do not move. So when you in a engineering dynamics, you're looking at the interaction between two bodies. Okay. So already explained how to find the friction direction. Okay. All right. Then there is a cable pointing into the center of the thing. Yeah. All right. So these are the forces you have in your free body diagram. Again, chapter 2, you need two kind of diagram. Left hand side is all the force, right hand side is all the motion. So on this diagram, you don't have any motion, but later as you do more exercise, you will combine left and right diagram. So kinetic diagram, because I have no space, so I just combine everything together on the diagram. So kinetic diagram, you have two directions. Again, kinetic, chapter 2, you only deal with acceleration. So don't go and put velocity. You put velocity, you put V here, means you go into chapter 1 question. Chapter 1, you deal with S, V, A, T. Here, chapter 2, you deal with acceleration. So acceleration in normal direction, tangent direction. Then you can find resultant. This is vector. Square this one, square root, you get the resultant. You can find the direction of the resultant. So far clear on the free body diagram? Try to understand the concept of solving. This module, if you memorize, you won't pass one. Because the question is a bit tricky. Okay. All right. Basically, you have everything on the table already. So you just solve F equal to ma equation. So you solve based on direction. You have two directions. One is tangent, one is normal. So you have two set of equation, F equal to ma, but in different direction. Right? So you look at normal direction first. What are the force you have in normal direction? What are all the force in normal direction? From this diagram? T. You only have T. This is tangent, this is tangent, this is B direction. Okay. So you have three equation there, normal, tangent, and B direction. So you have three equation. So each direction give you one equation, F equal to ma. All right. So then you summarize what you have in your free body diagram. So for this engineering dynamics, it's important you know how to draw free body diagram. You miss something inside your free body diagram, your equation will show wrong already. Because every time you extract information from what you draw. Okay. So MA, so I think I don't need to explain why suddenly your AN become V square over rho. This one you learned in chapter 1 already. Okay. When you have normal acceleration, the equation is rho of AN equal to V square over rho, and there's an equation to calculate the rho here. If the rho is not given, you need integrate 2 times, right, to find a value. So the rest you substitute. All right, tension, you know that you need to break this. You need to find the time to break this one. Okay, so you substitute value, rho is the radius 1. So you after you complete the normal direction, F equal to ma, you go for tangent direction. So tangent direction, you only have friction, and again positive is towards T direction. So friction is positive. So positive, your coefficient is given 0.1. ND you don't know. If you don't know, then you just put ND. Okay, or N equal to mass equal to 3, and your AT. AT you don't know, you just put AT. So currently you have 3 unknown. You have V, you have N, you have AT. So you need one more equation. So FB, these do not float outside, do not float. It just tell you that it will stay at that surfaces, then until the cord is broken. So FB, all the force in FB, here you have 2 forces. One is the weight, one is the N. Okay. So N, positive go up, W go down negative. You know mg, you know the mass, you know the gravitational acceleration, equals 0. So this is untold information. You look at the object, it doesn't float, so it becomes 0. So for chapter 2, you need to observe how the object moves, and then you try to see if it stay at that particular axis. For example, this case B, it do not float, so all the force will be in equilibrium, so equal to 0. Okay, so from here, from these 3 equations, F equal to ma in tangent, normal, and B direction, you can solve all the unknown. So here, the third one, ND equal to something. Once you find ND, substitute back here, you can get what is your AT, right? You have AT. Then this one also you can find the V also here. Okay, all right. Okay, now in this case, in T direction, because your acceleration is a constant value, your acceleration is a constant value. So when you have a constant value, you don't have any T equation or any S direction or any S equation, then you can use the 3 Newton motion equation. So since you already have V and T, V and A, you know that the initial velocity is 0. This is the final velocity that make the tension to become 100 Newton. So you have 2V already. So you have V, V naught, you have AT, you can find the time. Okay, try to understand the logic behind solving the question. Okay, so you solve it, you get the time, 5.89 seconds. So for this module, use at least minimum 2 decimal place, maximum 3 decimal place. Remember the unit. Okay, so to summarize the steps in chapter 2. First step, you look at the question, you know that it's chapter 2. First step, you write F equal to ma equation. All the force equal to ma. First step, you write all the force equal to MA, automatic you get. Then you start to draw free body diagram. So free body diagram, left hand side, all the force, right hand side, all the motion. So you can combine these two together. If you are already done a lot of exercise, you know that, like for example, this one on the slides here, I combine my motion, my kinetic together with my free body diagram. Okay. So again, I will encourage you to use different colors pen to represent your motion and force, just not to confuse yourself. Right? So any question so far? Okay. With four forces only: weight, force, external force, normal, and friction. Okay. So if you're unable to find, then usually how you find your force, like example number 5, you draw the axis out first. Right, you draw the axis and then see what is the motion. This is a linear, collinear motion. If it's linear, then you only have x and y axis. If it's a curve motion, circle motion, then you have tangent and normal. Tangent, normal, usually it deal with an and at. So there's an equation for an equal to v squared over rho. How to find at? How to find at? How to find acceleration at tangent? How to find at? If you want to find at, how to find? an equal to this equation, an equal to v squared over rho. But how to find at? What is the definition of a acceleration? What is the definition of acceleration in chapter 1? dv dt, right? What v you use? V in what direction? T direction. So there's a velocity in this direction. So when you integrate this v, you get acceleration in t. Okay, to this chapter 1. So example 6. Okay, example 6 is a ski problems. Right? So a ski, you jump from a curved surface. You know, from here, you have y equal to x squared minus 60, and then you have a reference point from A, 60 meter, right? So design the ski jump. You need to design a ski jump. In a photo, require noting the type of force that will be exerted on a skier and an approximate trajectory. If in this case, the jump can be approximated by a parabola. Determine the normal force on the 70-kilogram skier the instant he arrived at the end of the jump, point A. So you need to determine the normal force, which means the contact force. At point A, where velocity is 20 meters per second, what is her acceleration at this point? Okay, so you need to find the acceleration of this point. Now you look at this question again, how you know that this is chapter 2 question? How you know it's chapter 2 question? What information in the question there tell you that this is chapter 2 question? How you know? Chapter 2 question? Huh? Correct. You see the normal force, the force there. Chapter 2 deal with force equal to ma. So you see the question, you see force. This is not chapter 1 question, it's chapter 2 question and onwards, right? So there's a certain pattern of how we ask you question. All right. And this one, at the end of the jump, you focus on A here. And you have a information here. Velocity is 20 at this point. Okay. So what is your focus? You focus on the design, or you focus on the object? What help you to analyze? What help you to analyze? You focus on this chocolate colored object, or you focus on this red color object. Red color object. So once you lock on one object, you can draw free body diagram already. Okay. So again, you see the object move in a parabolic shape or in a quadratic shape. So this is a curvilinear motion. So it is a curvilinear motion. So this is a quadratic curve, positive A. Positive is a smiling face. Okay, it's a smiling face. So this is a curve motion. And at A, you have two directions. One is tangent direction. One is normal direction. How to find normal? You need to calculation. Normal AN equal to V squared over rho. The rho, there is an equation there. You need to integrate this equation 2 times. Okay, if you forget, you need to memorize. That one won't be given in the test or final exam. Okay, so we do the differentiation first before we substitute, right? So in engine dynamics, you see any curve, any curve motion, and the radius is not given, and the equation, you see any equation there, the first step is you do differentiation first. Differentiation 2 times means every time you see a curve without any radius, you do the integration and then find the rho first. Just in case, just in case, right? So dy dx, this is mathematical question. Y equal to 1 over 60 x squared minus 60. What does it become? What is the answer for this? Dy dx. Huh? 1 over 30 x, then plus 0. Okay. So this is the first one. What is the second differentiation? 1 over 30. Okay. Now, this is dy dx is a slope actually on the Cartesian plane. Dy dx is a slope. So the slope is what? If you have positive x, y equal to ms plus c. What is this look like? Is there. Okay. So at point A, at point A00, reference point here, you can put this one as your Cartesian problems. So this one AA 0, 0. So slope at A will be 0. The slope at here will be 0. Right? If you analyze, it's like you're analyzing the quadratic curve. What is the slope over here? This is quadratic. Y equal to ax squared plus bx. To find the gradient of optimum or maximum point, dy dx at this point will be 0. So same with this concept. So at this here, at point A, you substitute the coordinate here, 0, 0. Your slope will be 0. It means it's flat, tangent. Okay. All right. So the next one is to convert your question into normal and tangent direction. You draw free body diagram. Okay. Now, for engine dynamics, you are not required to draw the object in a very detail, but if you're not good in drawing, you can draw something like that, or you can draw like that. Okay. Okay. So it doesn't matter as long as you draw the object. And then once you draw object, you know there are forces in chapter 2. Go to the center of mass. Pick one point first. Okay, it's important. After that, we are in the particle chapter. Later, we learn about rigid body. You need to find the y-axis, I-axis, I-y-y. So we assume all the mass acting at the center of mass. So go there. The first force is your weight. Don't substitute value. You can write weight equal to mv, but don't substitute value first. Why? Because sometimes in engine dynamics question, you can straight away cancel the m when you equal the force. And sometimes the mass is not given or insignificant. Right? So when there's a contact, then there's a normal force. Four forces, external force, weight, normal, and friction force. So this one go this way, the motion go this way. So the friction will be this way. Okay, F friction or F. You can write F friction. Okay, it's important to write this word friction in your equation. If you just use F, I will assume this one is external force. Your free body diagram will be wrong if you do not make any clear notation. Okay, now this is a ski. You know ski, you skate on ice. What is the friction? What is the friction? You ski on ice. What is the friction? Huh? Zero, right? It's very smooth. Smooth surface, friction zero. Okay, so if you see question that doesn't tell you anything, in this question on ice, automatically we assume you know friction zero. Sometimes the question will say, a small children sleep on the floor. He's walk and then play with his friend, and then there's a pool of water. Somebody split on the floor, and the daughter, the children sleep when they step on the water. They sleep. Then the question asks you, what is the force act on the butt when it's fall down? So the friction also, it depends on how you ask. So like if it's very slippery, then zero. Okay. At point A, you draw two directions, normal and tangent. Why? Because it's a curvilinear motion. Normal, tangent direction. Then put in the force, weight, normal. And then is there any external force? Don't go and add external force. There's no jet coming in from the body. There's no